So let me bring up my source code here, and I will show you the basic lowdown on this. There is a bit more work, and let me find it. I got somebody in here. Green Zombie 2, where are you? Green Zombie 2, Lua. So now we want to open the Lua file. Let me close everything else besides this. And if we open up the Lua file that is generated by Texture Packer, what we're going to see is this long list of things. At the top will be a sheet definition, which basically tells Corona where the X and Y position and the size of each of the cells within the sprite sheet is. So each sprite is one of these little buggers right here. So attack E001 is going to be a position X100, Y2 in the sprite sheet, and it has an original size of 96 by 96 pixels. And there are a ton of these. So the trick is, how do I get these into a meaningful animation definition? So when I say a meaningful animation definition, what I'm talking about is, let me find it. Let's go ahead and create, this was a green zombie, right? Let's make a green zombie 2. So I have my own script, perhaps confusingly called green zombie 2, which is in the scripts folder. The one we were just looking at was in the images folder, because I left the images, Reiners, and then I left the sprite sheets and the Lua files together. But what I want to do is I want to generate a proper sprite sheet and some info definitions and a what is it called? Hold on. And a proper sequence. What is the name of this? I always call it sequence data, but it's basically a table that defines all the animations and what frames they are and how fast they run. Okay, we're 5 minutes over and I'm running us a bit out of time. But what I've done here is I know that this file is way, way, way too long, and the position of each of the sprites could be any random location as defined by Texture Packer when it put them together. So I need some way to put that together into a less arbitrary organization. The good thing is Texture Packer also produces this list called, super long list, called frame index, which we can extract. And then I can look and say, I know that I've got an attack animation that is facing east, and it's got 8 frames, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7. And I want to play these as the, oh, well, look at him, he's got 10 in this one, just to mess me up. I love it. Okay, good, wonderful. So there's 10. All right, whatever the case may be, we got 10 frames to go with the eastward-facing attack animation. I need to extract this information in a way that I can put it into a sequence table that I can later play it back. And we're going to run out of time, but what I've done here is I have basically imported the info from the green zombie Lua file that was generated by Texture Packer. I have extracted the sheet information, which was this business up here, and then I have generated a texture sheet using the an image sheet using the large texture produced by Texture Packer and the information in the info, the sheet itself. And then I've created this function, which we're just not going to have time to go through. But what it does, essentially, is I tell it, create for me a sequence using the walking animation, facing north, and it has so many frames, and then it assembles all that information and puts it into a great big sequence data table, which I will show you. So you can see it in the console. You can see one of these. Let me run this and show it to you. And give me just a second here. Here it is. This will look more familiar to people when they see it who've done this before. Normally you hand code these things. Am I running the desktop? Yes, I am. Hello, Corona, come on. And here it is. And escape. Let's make this bigger. Actually, let's just Control L. And what we've got is this massive table that's got an entry for every possible animation. So attack southwest, the loop is forward looping, so it plays forward. The frames that make up that animation are 67, 68, 69, 70, so it's discovered the correct numbers for those. It loops forever, so we set the loop count to 0. And one iteration through takes 1 second to play. Now, I did make a mistake. I just noticed that there are 10 frames, and I've only used 8. So I'll go correct that. But the thing is you can notice this is entry 24, and then these entries just go on and on. Out of all the animations I used, which were walking, disintegrate, attacking, and bend hit, each of these has a north, south, east, west, northeast, etc. facing animation, which I would have to go in and read this file, go, oh, okay, attack east 06 is, let's go find it, let's just choose one arbitrary. Walking to the southeast, frame 1 is 281, and I would have to type it in. I'm too lazy to type it in, so I use this information out of the image sheet. I'm using the wrong name here. The texture packer provides us the module they provided, and I extract the correct frames to build up this table that is then correctly formatted and looks like this.
So you're just automating that mapping that texture packer automatically generates, right? That file that it automatically spits out. You're mapping that automatically with your script.
Right. I'm taking information they've already provided me and then mapping it to the correct sequence setup that I need to play that animation a certain way. So this is the kind of thing that requires a certain knowledge of how animations work. And I think what we can do to make this a little simpler is we can talk to it briefly again next week, and I will show you a very short example so people can understand how these things are put together. And then they can understand why it would be hard to take something that's got 304 frames and to manually assemble it versus doing something and discovering the details and putting it together with a little bit of an algorithm. Because you can see, for me to assemble this would be hundreds of lines of work or lots and lots of time on my part, depending on how you look at it. Whereas I just put it together with, like, I don't know, 30 lines of code to generate it. Nice. And the more I want, the more I put in. So it's quite easy now. I just have lists.
Okay. Well, yeah. Let's do that next time. Let's look at the simple example.
Okay. So I've gone way over, but I just want to say one more thing before we depart. Am I here? Where's my thing?
You're still here.
Is my camera dead?
You are on a black screen right now.
Oh goodness sake! There we go. So we've narrowed down how we're going to move. We've said we're going to move along cardinal directions, forwards, backwards, left, and right. We're going to use a reticle. We're going to use Reiner's art, and I haven't settled on everything else. The mechanics of the game are shooting. The one thing we haven't chosen yet, and I think we should just choose it right now, is are we going to do an arena-style game, which is basically the players come at you, you're always in the center of the world in a sense, and they're constantly trying to mob you and kill you, which is a very standard shooter design. So the enemies are always coming at wherever you're at, that's the center of their locus, their world. They're trying to kill you. The other way to do this is to take that up one level, which we can do, and add structure elements to the world, obstacles. So things in the world that get in the way of them and you, but you can use them as a defensive structure to say, you know, zombies are on the other side, they can't quite get at me. And what that will allow us to do is explore not only using elements in the world that block strategically, but we can ramp that up and do an exploration of A-Star.
Well, if it's
a pathfinding technique.
If it's the choice between ice cream with sprinkles, I'll take the sprinkles.
Okay, so we're going to go with the ice cream with sprinkles?
Yeah.
And the only other part of our game that I've decided for sure we're going to put in is Reiner's, who's got, like I said, he's got a ton of awesome like traps and stuff. And so what we're going to do is all those things with pickups that generate either more powers on your weapon or traps. They will generate a trap when you walk over them, which then will persist for a certain amount of time and kill any enemies that get near it, and then they'll go away. So that way we can introduce more of Reiner's animations, so I can show you more variations on how to use them. And we can explore the concept of using traps as a defensive mechanism in a shooter. And that will give us, I think, a well-rounded first shooter.
Sounds like fun. I like it when you get excited about these third-party animation packs.
Well, this is like the first time I've really gotten to like start pulling these things together where I can use them and show them off to people. So I've done several of these for myself as sort of like demos and proofs of concept, but not use them external.
Do you think we'll have time to get into the tiling next time? Or will we need to save that for a whole separate?
I think we should save that separately because I haven't decided for sure what we're going to use as our backgrounds. I like the Lost Garden tiles. You saw them there. They're slightly out of scale the way I use them. And he provides a rule set for mapping them together so you never get... he's designed them so that certain tiles go with other certain tiles and they are seamless. But there is a rule set that is quite complicated. You've got to embody it in an algorithm so you can generate randomly and still have seamlessness and not have the wrong tile next to the wrong tile. So that would be, I think, like a whole discussion. Because we want to generate our background based on some rules and have it be seamless. So we could do that. It's just I don't think I can discuss that in 5 minutes.
Yeah, no, that's good. And we don't want to rush through any of this stuff. I mean, if we need to stop down on something and explain it more or do multiple segments, that's I think that's totally legit. So
yeah.
Okay.
So next week what I'll bring is like a much more functional game, and then we can start to break down whatever element suits our fancy, which is probably going to be, I think, aiming and navigation of the player first next week.
Okay. All right. Well, in the meantime, I'm talking to you. You need to go out and download the code. The link will be in the show notes. In the description of the video, if you're watching this on YouTube, is a link back to the blog post on coronalabs.com where all the show notes are listed. We have all the resources there, so that includes the code that you can download or any of the third-party animation packs or anything that we've mentioned in the show will be in those show notes. So we got a couple of questions over the weekend. People were wondering where the source code was for some of the previous shows. Check the description. Go to the blog post. Links are in the show notes. So until next week, have a great week and happy coding.
Adios. Bye.